Hello, and what is becoming an increasingly common occurrence, I made an error in the last, no, not last video. When I post this, it will be last Tuesday's video, Cosmic Balance by Narrator. And this was pointed out to me by both Majax Plop and KL, who realized the mistake. So the mistake that I made is at this point in the puzzle, I was looking for, I figured out that there had to be one more, exactly one more galaxy in here that wasn't colored. And I kind of lazily, I don't even remember what color I used now. Maybe put, no, not yellow, maybe purple. Um, a new galaxy here like this, and then said this has to go up and green has to go up to fill it in. But that actually isn't the only way to do it. Another thing I could have done, or what one could do here at this point, is have a galaxy like this. Right? This galaxy is also possible from the markings that I have. Now, it doesn't turn out to be right, but I made an error in excluding it. There's no logical reason to exclude that possibility. So I tried to think of I tried to find the most direct way to get here so it didn't kind of ruin the rest of the solve. And you can basically do it in two more steps. So from here, you can use logic that I did do in the video solve, just in the wrong order, which is looking at this galaxy. You can see that this cell has to be a 1 because these sum to 12. So this has to sum to 15. If this is 6, we get 1, 8. If it's 8, we get 1, 6. Either way, this is a 1 right here. And then from here, I can look at this white Kropke dot and say, well, what can go in this Kropke dot? Well, it can't have a 1 in it. It can't be 2, 3 because of this cell. It can't be 3, 4 because of this pair here, so neither of them can go here. So suddenly this cell already is limited to 6, 7, 8, 9, but it's also not 7. So my choices are either this is the 5, 6 pair with the 5 on the left and the 6 over here, right? Or this is an 8, 9 pair across the crop. Yeah, those are the only two things that can happen here. Okay, so now with those markings in place, let's think about this potential galaxy again. If this were possible, or if this were the way the galaxies actually went, what I would need is, again, because this would sum to 27, these would sum to 18, but I already have an 8 here. So that would leave us with, it would have to be 1, 4, 3, 2 as possibilities. Right? That's the only way I can make that work. But here, and then these two cells would have to be part of the green galaxy. Because this is 27. Now these three are 18, but that's a 2. So this would have to be total 16, would have to be a 7, 9 pair. Well, now I run out of digits I can possibly put here. Because either this is a 5, 6 pair, in which case that's a 9, so this can't be 9. Or this is an 8, 9 pair, in which case this can't be 9. It also just can't be 7. So this just doesn't work. So once you realize that, then you can properly put in the galaxies like here and continue to solve. I guess those would be gone. Continue to solve, not by color. And continue to solve as I did in the video, but you need to do that step first. Otherwise, you're cheating like I am. So sorry about that, narrator. And I'm actually recording this after I already recorded the video that I'm going to put up Tuesday. So I'm just going to splice these together awkwardly. So that'll be into this, and I'll give you another introduction into the next puzzle. But anyway, again, apologies to narrator and to everyone else for making that error. All right, thanks. Sorry, one more quick interjection, then we'll get to today's video, I promise. Yesterday, someone else made the exact same mistake that I made on this puzzle. And KL, who pointed out, it was one of the two people that pointed out the error that I made, commented on that video that actually there's a much better way to figure out what to do here than what I just showed you, which is that this 5 actually lights up the fog right here. So I can see that there's no Kropke dot between these two, so I know that this galaxy has to get bigger, and that's how you actually know that the Peach Galaxy extends. Okay, sorry, that's it. I just wanted to point that out that KL had a much more clever way of solving this than I did. Anyway, back to today's video. Thanks. Hello, and today I have the puzzle Trypophobia II by Abdul the Killer. Now, the very first puzzle I ever did on this channel was by Abdul the Killer, and since then, I've actually started testing a lot of their puzzles. I haven't done any more on the channel because I've been testing them, and so I haven't, there's not really an opportunity to do a finished puzzle live that I haven't done before. So, but he said, look, this puzzle I know is like one of my best puzzles. I don't really need you to test it. Why don't you go ahead and record it? So that's what I'm doing, and this should go up concurrently. So I have it a little bit early, and I think it should go up concurrently with the Logic Masters Germany posting. Although I don't have the link to that yet. So when this video first posts, it will have a direct link to the Sudoku pad solve link, but it may not have a Logic Masters Germany link for a couple hours until I am able to find that and add it to the description. But anyway, you can still play it. Go ahead and click in the link to go play this. I'm excited to try it. I hope you are too. I really like the shading rule, and I think the new twist that he's added to it with the odd even is just really, really nice. So, because there is a Trypophobia I, which I guess I'll also link, which I had done in testing. And anyway, yeah, that's all the preamble I'm going to do. So let's get into the rules. So we have two rules basically in addition to Sudoku rules. So Sudoku rules are digits 1 to 9 in every row, column, and box, no repeats. Now there's an exhaustive, meaning there is a negative constraint on the shading rule, which means if a cell is shaded, then within its box, so for example, this cell, because it is shaded, within its box, it is adjacent to, and adjacent could mean diagonally in this case, but it is adjacent to the digit, if the digit that is 1 below it. So for example, if this were a 5, it would have to be adjacent to a 4, somewhere around it, which from what I just did, maybe gives you some clues about centers and why they're so important in this kind of a rule set. If they are unshaded, then they are not adjacent to the digit 1 less than it. So, right, so these digits are not adjacent to the digit 1 below it if they exist. Circles are odds, and circles also have a negative constraint. So all of the odd digits are given by circles. And if there's not a circle, then it is not odd. It is in fact even. So those are the rules. That is it. I'm going to restart time and start it. And I'm going to immediately start, like I do in all of his puzzles, by looking at the center boxes. So as I said before, the centers are very important. And there's two really important things about the center. First is they're pretty much always shaded because they see everything in their box. The only reason they wouldn't be shaded is if there's no digit that is 1 less than that digit. And here's the only box where that's true, so that has to be a 1. 1 is the only digit that doesn't have a lesser digit in the 1 to 9 set. So this digit has to be 1 because it is adjacent to everything else in the box. So if this were higher than 1, it would be adjacent to its digit, and so it would have to be shaded. So none of these digits are 1 because they're shaded. The other thing that's really important about the middle cell is that if it's shaded, which almost all of these are, then unless it's a 9, 9s are a little bit tricky, but unless it's a 9, the digit that is 1 above it is also going to be in a shaded cell. So as an example, I'll put a 2 here because I know it can't be 2 because it's odd. If this were a 2, 3 is going to have to go in one of the shaded cells because I know wherever 3 goes in this box, it's adjacent, including diagonally, to the center cell. So 3 will see the 2, so 3 has got to be in a shaded cell. Now if it's 9, right, then there is no 10 in the puzzle, so I can't make a logical inference like that. But for every other digit, that's going to matter. So those are the two right away nice starting tricks. I mean, I'm tempted to like color the even and odd cells, but I already know them all. They're all just given here. And when I did Trypophobia I, I just happened to look, I just happened to look in a box and see this odd, even, and shading cell just like fill in the entire box, just looking at that box. And so I don't think I'll be so lucky to just guess at that again, but I'll give it a try. And I guess I'll start here because I have a digit at least. So, so how did I do that? I'm trying to remember. So let's start. I see. I don't like this box as much. What are really nice are even digits that are on an edge like this, but not a corner. So let's try this cell. This cell, because it's even, there is a digit less than that, right? It's not 1. So there is a digit less than that, and it's not next to it. So if I call this, let's say I call this x. X minus 1 is somewhere over here. And x minus 1 is odd, so it's somewhere over here. So let's call this I, and I'll count down. So one of these are H. So now where's G? Now I have to be a little careful because this could be 1. But suppose it's not 1. If it's not 1, then G is even. And so it's not in any of these 4 cells. It's even, and it's not adjacent. So these cells would be adjacent to wherever H is over here. So G would have to be over here, but it would have to be even, so it would be over here. So G would be something like this. Now where's F? Again, I have to be careful because F, well, no, in this case, actually, there is an F whether or not G is 2. Like G might not be related to H. Oh, but yeah, so the chain's going to break down in a second. When I did it the first time, I happened to just pick on a cell that it just had to work, and it was really nice. But let's say this goes down. Uh, no, it's not the same. So let's do it this way. If this is I, H is going to go in here. Now this is another even cell on an edge. So let's call this, so I don't confuse the fact that these necessarily have to be close together. Let's call this C. The same logic, B is going to be one of these cells. But again, B can be 1. And now I'm running out of even cells. So this is another even. Let's call this one F maybe. Now E is an odd cell, which is right, but that could be anything. Yeah, I'm not liking this cell so much. Well, let's get rid of that. Let's try a different one. Can I find, here we go. Let's try this one. So if this is H, where is G? One of these. I saw the same pattern. I should have gone back and looked at Trypophobia I before doing this to see exactly how I did the logic because it was so nice. And it's not quite working the same way here, I don't think. Or maybe I just don't remember. Oh, well, there we go. Let's do this one. There's 3 in edges here. Oh, but that's not even. Well, that's okay. Let's try this one. Let's call this H. G is going to be one of these. Let's call this F. Let's call it C. Ah, that's even better. If this is C, then this is B. And therefore that can't be G as well. This is A, because by C, again, I need an odd digit that is not adjacent to it, so none of these. And it's odd. Oh, but it doesn't have to be shaded. Shoot. No, I made a mistake. That could be B. So that's G is in there, B is in there. What are my other bins? Here and here. Well, this is 1 less than one of these digits by the rule I said before, because it's not a 9, because it's even. So the digit above it is going to be one of these. Oh, that's even better down here. Let's do this for a second. Let's call this A. This is 1 higher than A, because B, this is even. So there's a digit higher than it for sure. And by the logic I explained before, 1 higher than it is here. So that's B. But this could be 9. This could be 9, 8. But let's suppose for a second that it's not 9. Where's 8? It's got to be, or sorry, where's the digit higher than this? Where's C? It would be here. So that would be C. Because these 2 are shaded. So that would have to be C. And then D would go out here. E would be any of these. Yeah, at some point we're into too many choices. Hmm. And then here, this is either the digit above it or this is 9. Yeah, but I'm having a hard time seeing why. So let's keep thinking. Let's go back to this one. C needs B. B could be 1. But if B is not 1, where's A? The digit less than B. Could be here if that's B. And that could be A. Or it could be out here. Or no, it's got to be even. Sorry. So if it's A would be here. Anything that's not C. Uh, okay. I don't think that's actually useful. Maybe I should just think about ones. So where's 1? Where's 1 in box 8? It's got to be here. Where's 1 in box 2? It's got to be here. Same thing over here. That's kind of an X-wing on ones. Get a 1 here. 1's got to be one of those. It's here. It's down here. So I get another X-wing on ones. That's not a 1. Yeah, so let's figure out where all the ones could be so that if I place something somewhere else, I can say it's not a 1 for sure. So let's keep going. Let's go back. This one, that one doesn't work. Well, that's not a 1. And it's not adjacent. So the thing below this is one of these two, which is also not 1. So if it's this one, if this goes to this, and that leaves, it's got to go back to odd. That leaves one of those. If it goes to here, that leaves one of those. Okay. This goes to one of these, which goes to one of these either way, interestingly. I'm not seeing it. Oh, that's 2. I'm so sorry. That's 2 definitely sees this one. So even though it's not shaded, I can do the same thing. 2 sees this one. That's a 2. I'm so sorry, Abdul. Uh, yeah, that's a 2. And now where is 3? 3's got to be odd. Not this one, not this one. 3 is one of these. And then where is 4? It could be here with that, or here with that. So these are 4, 6, 8 in some order. I wonder if I keep going higher. Like, is this, whatever this is, I mean, clearly isn't going to see the other evens. All I know is it's not 3. But this one has to see one of these. This one has to see this one. Okay, so this one sees this one. This one sees this one. This one has to see this one then. So, oh no, because this could see 2. Shoot, no, that's wrong. That's wrong. This could see 2, or this could see 2. But if this is 3, then this sees this sees this, that sees 2. So we get a chain like that. Well, not a chain, because this goes to this, that's 3. Which it could be. Like if this is 5, 4, 3, that works. But if it's 7, 6, I have to go 5, 4. Oh, these can't be, well, that's only if that's that. Okay, let's think that through again. I don't think this can be, so this could be 3, 5, 7, 9. I don't think it can be 7. If it's 7, it has to be next to 6, which would have to be here. 6 would need to be away from 5. But if this is 7, then that's 3. So it'd be 7, 3, 6, 5. 5, and then 4 would, yeah, this doesn't work. If this is 3, that's 5. Because if this is not 5, then whatever is one lower than it, if it's not 3 or 5, then whatever is one lower than it will go here. 4 would have to go here, which would break the 4s on 3s. So this is 3 or 5. If this is 5, that's 3, 4, and then I have to restart. This would be 9 or 7, that would be 6 or 8, and these would be the other 2 digits, whatever they are. If this is 3, now 4 is up here for sure. 5 could go here still. Like this would see one of those, this would see one of those. There's one more left somewhere. I don't think I get anything from that. Okay, maybe that's all I can do here for now. Yeah, any of these could be 2. Well, yeah, now that I have the ones that are real, let's think about 2s. So if this is 1, 2 could be here or here. If this is 1, 2 could be here or here, but that's everything. All the evens. This could be 2, this could be 2 with this. This could be 2. Let's get rid of A and B here. This could obviously be 2 as well. So no help on 2s here. Those could be 2, those could be 2. 2, 2, 2, 2, yeah. 2 could be here or here or here or here. 2, 2, 2, 2. No, I'm not getting, oh, 2 is at least here. Okay, whoops. Sorry, that 2 is in one of those because in the evens I have a 2. 2 is in one of these. So I get a 2-1 separation here. Um, let's think about, well, let's think about 2s. Let's do this last one. 2. This can't be 2 at least. Any of the others could. Oh, but actually I have an X-wing and 2s kind of. So 2 is up here, which is no help. But, oh, but it does tell me 2 is here because I again get an X-wing on 2s of sorts. In fact, these 2 digits are these 2 digits uh, by that same X-wing logic. Like all the evens are here, 2 of them are here, so the 2 go here. Maybe I should just be thinking like in like region terms on the even odds. So, um, so this goes here. I think that's as far as it goes. Well, then that would go here and here. Hmm. Almost feels like it's worth marking, but I don't know that it is. I'll mark those 2 at least. It's very bright in my eyes. Hopefully it's better on yours. Where do I go next? Let's see. I'm right here because that's not 1. Could go to either of those though. Yeah, I don't see it. 3, 2, 1. Where's I know a lot if this is 3, I know a lot. What if this is 3? I tried it, but for some reason I want to come back to it. That's not 4. One of these is 4. I don't know. That's not a 3 because it's not next to any of the places 2 could be. So that's pretty high. So it's even. And this is even as here, which I guess I kind of knew. But the even one less than this has to be here because it doesn't see any other evens. The even less than this has to be one of these. Even one less than this, because there is one, because it's great, is one of those. And one of these is 1, and the other one is the other one of these. Ugh. It just isn't enough. Now this digit could be any of those by like region sum like logic, but also by the fact that the pink proximity works out. These 2 are these 2. I don't know that that gives me anything though. I'm gonna mark those purple. Now, this is turning into a color coding, which I am not used to for these puzzles. Where's 3 in this box? That's odd, but almost anything. That's not 3. That could be anything else. See, the problem with coloring all these, I'm going to get rid of this coloring because I think it's obvious enough that if I ever get any digits, whoops. If I ever get any digits or markings, I'll remember because I can't see the shading when it's colored. And I could put a white flash in to help me see the shading, but I think it just gets too confusing for me. Could you do something like, what if this is a one? Does that break something? Because I get a lot of traction if that's a one. No, I still get next swing. That's okay. Yeah, no, I don't see any problem with ones being pretty much anywhere. All seems to work out okay. So what's the trick? This has to be one less than one of these. Do I need to just keep thinking about twos? Two. Any of these could be two, though. Like, Um, two is one of these. Ah, so that's not one. Two is one of, there we go. Sorry. This is not hard. Two is one of these because two eliminates the other evens. So one of those is two. This one doesn't work with that as two or that as two. So that's not a one. Ones go here. That's not a one. This is a one. Oops. Um, now I still get either one of those as possibilities. But let's keep, this seems like the right agreement. That's no longer a two. That's a two, which makes that a two, which means two is one of these. That's not a two. There we go. That seems like the intended path here. Twos, twos. Can I do more? Any of those work. Twos down here. Sorry, where? That's a two. Twos, twos, twos. Yeah. No, I don't see any other 2-1 interactions. So let's think about, now I have some twos, let's think about some threes. So where is three? Not here. Oh, it's one of those. Yeah, those work. Um, I've had that two forever. Let's think about this two. Where is three? Not here, not here. Three is now on this line. Three is here or up here. Yeah, that ran out. What about here? Three is not there actually. So it's almost like something. If three is either of these, that's two. But three could be up here, and that leaves either two. But the reason I'm thinking about that is I have this kind of elimination here. It would make a lot of sense for one of these to be threes. Like this. Oh no, this can't be three. Huh, that's wrong. That can't be three. So one of these is three. So one of these is three. So one of these is three, but not this one because it's not adjacent to a two. I almost had a 1-3 pair there, but this one is marked. I'm gonna mess that up at some point. One of these is three. Did I actually put any threes in or just some pencil marks? I think just pencil marks still. Where's three here? Any of those? Any of these? I don't know anything about two here. Okay, let's think about fours then. Four works here, not here with these. So this becomes 6 or 8, actually. I'll mark it that way. And so whatever's less than this has to be here. I can do anything with, that's not 4. So 4 is over here. So that's not 4. Okay. One of these is a 4. One of these is a 4. So 3, I mean, this could be 4, and then 3 could be anything. Once you get something in the center, it really just kills that momentum, I think. What about here? Fours, could be any of those still. Here, 4, 4, 4 all work. Interestingly, if 4 is in the bottom, that's 3. Potentially interestingly. So if one of these is 4, that's 4. That's 3, that's 3. That's 4. 4 is in here. Getting too much look ahead, I think. Where is 4? Can I do something now with this being 3? Because now if this is 3, it's not just one of these. If this is 3, that's 4. And then this has to look at this. So this becomes 7 or 9. 3, 4. These are a 6, 8 pair. This is one more than whatever one this is. This is one more than whatever one this is. And this, and then this becomes 5. So one of the, that's quite a stretch. But so if this is 3, that's 5. If this is 3, that's, oh no, that's 4, so that could still be 5. I'm wrong. But this can't be 5, actually. Right? Because if this is 5, this is 3, this is 4. Oh no, that does work. No, I'm just full of it. That works. Could this 4 makes this 3 and makes this 4. And this becomes a 2, 4 pair. No, 4 can't go here. 4 can't go here. Sorry, that was, but it could go here. Oh, shoot. I thought I had something. 4 is not here, but 4 is, because this is adjacent to both places that 3 could be, either one of these. So 4 is here, which means 4 is one of these. But that doesn't tell me which way the 3 goes. This one by itself could be either one. This just adds more possibilities. But I now have an X-wing on 4s. So 4, this becomes a 2, 4 pair. This becomes a 6, 8 pair. This becomes a 4. There we go. 4 has to go next to 3. So 3 is in here. So where's 2? If this is 3, that's 2, and that's 1. That works. If this is 3, that's 2, either one. If that's 3, that's 2. So that's not 2, no matter what? No, 3, 2, 1. That's okay. I don't know why I said that. But this could be 2. 4. I keep having these small breakthroughs, and then that's it. Let's think about this. The one less than that is here. The one more than this is here. So that's 7 or 9. The one less than this is here. Could it go here? Like 6, 5, or 8, 7. Problem is, if it's 6, 5, that becomes 4. But if it's 8, 7, oh, 8, 7, 6. That's actually how that would go. Oh no, that doesn't work. Does this work? 8, 7. No, this can't be 8. This can't be 8. Because if this is 8, this can't be 7. So if this is 8, this is 6. So this is 7. And then 8 and 7 is just not work. So that's 6, that's 8, that's 9. I love that. So what's really nice about these odd circles is you really get to look at numbers all across the spectrum kind of at the same time. And it's really neat. This is 5 or 7. Well, this is 6, so 5 is here. 5 is here, which means 5 is here, which means 5 is here. I have so many markings in this puzzle. I'm gonna, oh, one of these is 5. Either way, that's 4. If this is 5, that's 4. If this is 5, that's 4. So we get a 4, 2 locked up. 4 now has to go here in box 4. 2 has to go here in box 7. And that gives us a 4 here. And that gives us our 4 here. which means that's not 3. That's 3. That's not 3. 4, 3, 2, 1. Where's 5? Anywhere. Anywhere, 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 anywhere. This is adjacent to something. So this could be 5, 7, or yeah, this could be anything. Okay. Um, 1 in this row, 1 and 5 are kind of marked, and 3. So we need 8. Oh yeah, that's 8. And we need 7, 9 somewhere. But this 8 means 7 is up here. So this is a 5, 7 pair. That makes this a 1. That means we get, I don't know, but we get a 1 up here. This is now a 1, 3 pair. This is a 5, 7 pair. So this becomes a 3, 9 pair. That's no longer 9. This becomes also a 3, 9 pair. This becomes 1, 5, 7. This is a 1, 3 pair. And this just works. Either way you put it, this all works. Rough 5. That's not 5. That's not 5. That's 5. 6 can't be here, so it's got to be here. That makes this 8. That puts this way. That makes this 5, 7, but I must know 8 can't go next to 7, so that's, oh no, 9. 8 so that's 9 and 7. Does this work? 9, 8, 7, 6, 5, 4, something, 2, the other. That works. That's 5. That's 7. Yeah. Now we're got to be almost done. What do we have left? 2, 3, 4. We need 5, 7, 9 here. That's a 5. These are 7 and 9. I must know. That can't be 7. So it's 7, 9. 5's got to go here. 1, that's 5. That's 7. So now that's 5. 3 could go anywhere. What's this? Not 7, not 5. Not 1. So it's 3 or 9. You got a 3, 9 pair here. What's left? 4, 6 is a 2, 8 pair. So this has to be a 4, 6 pair. This can't be 6 because it's not next to 5. So that's 6, that's 4. 7 has to go in a shaded cell from the center. So that's 7. This becomes 1, 3, 9 as possibilities. Is there anything we can get rid of? No, because 2 and 9, yeah, anything here is going to work with that. What this? So these two have a correspondence. Oh, right here. 3 is next to 2, so that's a 3. That makes this the 9, makes this the 8, that's the 2. 1, 3 work either way. That's a 9. The other one here is a 6. 7 could go either way. 6 either way. 4 either way. Okay, so I don't know from there how it goes yet. That's 4, 6. These are almost anything. Let's come back to that. This 4 has to be next to 3, so that's 3. Where does 5 go? Not here, not here. So that's 5. Where's 6? Either place, but not there. 6. Where's 7? Either place. So these are 7, 9. That's 8. I know how those go. Makes this 9, 3, 7. This is next to, it's odd, so that has to be 4. That's not 4. I knew that before, but I just missed it. This is a 2, 8 pair. What do I have left? That's 1 or 3. I'm gonna get rid of all these markings. These 4, 2 are taken, so that's 6 and 8. So one of these is 5 or 7, but not, this can't be 6 because 5 can't go in here. So this is 8, this is 6. 7 goes in here somewhere. We also need 1, 3, and 9. 1, 3 pair here. So this is 7, 9. 5 is definitely here with 1 and 3. Can I do better than that? This can't be 9 because it would conflict with the shading on 8. So that's 7. That's 9. That can't be. Oh, no, it can. Lies. 4 has to be next to 3. So this can't be 3. 2 can't go next to 1. So that's not 1. Also, it's shaded. 3, 2 works. 5, 4 works. 5, 3, 2. Yeah, all of these work. So that's just Sudoku. All of these are just Sudoku that will unravel at some point. Yeah. What about this box? Same here, right? 2, 8, 7. Yeah. 6, 5 doesn't work. So 6 has to go next to 1. 5, that doesn't unravel these at all. But that tells me here's my 1. Doesn't tell me anything about 2s, but Sudoku will. Oh no, it won't. Almost. Two's here. Three is, well, I have an X-wing on threes of sorts here. So that's my three. So that's not two, that's two. That makes this 8, 2. 4 can go any of those places, but not here or here. So that's a 4 by sudoku. 5 has to go, not here by shading. 6 can't go here, so it's got to be there. That makes this 8. This is 7, 9 in some order. That can't be 9 because it's adjacent to the 8 and unshaded. So it has to go this way. We get 1, 3, 5, 1, 3, 3, 1, 3, 1. And I don't know if this is right because he didn't send me a solution and it's not in the thing. But I will go through and make sure it's right before posting. But anyway, sorry for the very slow start. There were some things that I really should have seen earlier. But anyway, that great puzzle. Thank you. I'm the only person to solve this. I think that's the first time that's ever happened. So thanks, Abdul the Killer, for actually let me just quickly like this puzzle as I've become want to do. So thanks, Abdul the Killer, and thank you for watching. And I hope you tried the puzzle and I hope you enjoyed it. All right, bye bye.